Good morning, students. We already discussed the ionic mobility, ionic speed, and determination of ionic mobility and the ionic speed. Today we have to discuss about the transport number. So, in the transport number, we have to discuss today. Transport number. Transport number. Transport number means the fraction of the total current carried by cation or anion or an ion is known as the transport number. That means the fraction of the total current, the fraction of the total current, total, the fraction of the total current carried by ion by an ion is known as transport number is known as transport number or transferency number or heat of number. That means whatever be the current carried in an electrolytic solution by the ion, the fraction of the total current carried by an ion is known as the transport number. It is designated as the transport number. The transport number is designated as T plus for transport number of cation and T minus for transport number of anion, or you can also write like this: Tc transport number of cation and T minus T anion A transport number of anion, or you can write also transport number of cation Nc and Na is the transport number of anion. So this is the symbol how we can identify the transport number, how we can designate the transport number. Then how the how the ions are formed, how it is current carried, that depends upon the electrolytic solution. Let us consider a electrolytic cell. Let this electrolytic cell contain an electrolyte solution. It contain an electrolytic solution. It contain an electrolytic solution. Let anode and cathode, two electrodes are dipped in it. Suppose we know that we always left hand side is anode, right hand side is cathode. It is cathode and it is anode. Now the two electrodes are connected with a battery. Now when you on this battery, the electric current will flow in the medium of the electrolyte. So here you can remember that here the electron is not transferred in the electrolytic medium. Here ion is transferred. That means the anion means negative charge, move towards anode. All negative charges move towards anode and all positive charges move towards cathode. And while they are moving, they carry the current. So here electron is not responsible, here the ions are responsible in order to conduct the electric current. So this conduction depends upon the speed of the anion and speed of the cation. If the cationic speed is more, if the ion speed is more, then the more current it will carry. Suppose I tell that the speed of anion is more than cation, if the speed of anion is more than cation, then the current carried by anion, the current carried by anion is more than the cation, because the speed of the anion is more than that of the cation. In this case, what we did, now we do that, we take, suppose we consider sodium chloride solution. So sodium chloride is a strong electrolyte, it undergo 100% ionization. Suppose we consider take some 50 ml water, 5 gram sodium chloride we add, all sodium chloride ionizes and it converted into Na plus and Cl minus. Na plus is called cation, Cl minus is called anion. Now when we make the switch on, then the anion moves towards anode, cation moves towards cathode. This is called electrolysis. That means when the anion, that means when the Cl minus move towards anode, it loses electron and gets discharged. That means when the anion moves towards anode, it loses electron and gets discharged. Similarly, when a cation moves towards cathode and accept one electron and gets discharged. That means here anion moves towards anode, lose electron and gets discharged. Similarly, a cation moves towards cathode and gain electron and gets discharged. So this is called electrolysis. When during the electrolysis, what happens? Now anion moves towards anode, cation moves towards cathode. In this case, you see that whatever the valency of chlorine and sodium is same. Chlorine valency is 1, sodium valency is 1. So both cases the valency is same. So in this case, that means when the electric current is flow, then the anion moves towards anode, cation moves towards cathode. So the current carried by the anion per second is called as the transport number of the anion. Suppose I tell that in 1 second, the number of anion, the total number of anion means total number of anion, that means in this case Cl minus, total number of anions discharged is the current carried by the anion, is the current carried by the Cl minus. So this is whatever be the current carried by Cl minus during 1 second or total electrolysis time, maybe 5 minutes or 6 minutes. Suppose the electrolysis takes place 5 minutes. Suppose this electrolysis takes place for 5 minutes. In 5 minutes, whatever the total number of anion get discharged at anode and whatever be the current carried by anion is called as the transport number of anion. Similarly, in 5 minutes, the total number of cations get discharged at the cathode. That means, suppose I tell that 500 cations get discharged at the cathode. That means 500 cations move towards cathode, and these 500 cations are responsible for the transport number of cation. Similarly, suppose 500 cation move means 500 anion also move. Suppose I tell that in 5 minutes 500 anion, in this case chlorine, move towards anode and also get discharged. So when the 500 anions move towards anode and gets discharged means the transport number, that means the fraction of the current carried by these 500 anions is called the transport number of the anion. So the total current carried by the cation and anion, but you can tell that the total number of ions, number of ions, the total number of ions discharged, the total number of ions discharged at each electrode, at each electrode, the total number of ions discharged at each electrode is directly proportional, is directly proportional to the speed, to the speed of cation and anion, cation and anion. That means to the sum of the speed, to the sum of the speed of the cation and anion. That means I tell that suppose in 5 minutes 500 anion move towards anode, and these all the 500 anions get discharged, and the total current carried by these 500 anions is called as the transport number of anion. So that transport number of anion depends upon the speed of the anion. That means I tells that according to the Faraday's first law of electrolysis, the, the total number of ions discharged at each electrode, the total number of ions discharged, the total number of ions discharged at each electrode, at each electrode is proportional, to the total current passed through the electrolytic solution, by to the total current passed through the electrolytic solution, passed through the electrolytic solution. That means I can tell that the total current carried by the cation and anion. That means the total current carried is directly proportional. Suppose I tell that speed of cation plus speed of the anion, I tell that this is called the speed of cation. This is called the speed of anion. That means why I write the speed, because the number of ions discharged at each electrode depends upon the speed. If the speed is more, then more current it carry. If I tell that the speed of the anion is more than that of the speed of the cation, then the total current carried by the anion is more than that of the cation. So the total current carried is equal to, by directly proportional to the sum of the speed of the cation and anion. Sum of the speed current carried by the cation and anion. So this current carried depends upon the speed of the cation and speed of the anion. If the speed is more, current carry also more. So if I tell that the transport number of cation, the transport number of cation, I tell that T plus I write the transport number of cation depends upon what? Now current carried by cation, by total current. That means the transport number of cation is equal to current carried by cations. Current carried by cation means how many number of cations discharged at the cathode, and the number of cations discharged at the cathode is depends upon the speed of the cation. If the speed of the cation is more, then more cations are discharged and more currents are passed. So the current carried by cation is equal to U plus divided by total current. Total current means total current of speed of the cation plus total speed of the anion. This is called the transport number of the cation. Similarly, we can also write the transport number of anion is the current carried by anion divided by total current. Total current carried by anion is equal to total current. That means the transport number of anion is equal to speed of the anion divided by speed of the cation plus speed of the anion. This is called the transport number of anion. That means if the speed of the anion is more, the number of anions will move towards the anode is more, and more anions are discharged, and more anion movement means more current is passed. So we write here U minus U plus by U plus. This is the total current. This is the current carried by the anion. Then the transport number of cation plus anion, the transport number of cation plus anion is equal to U plus divided by U plus U minus plus U minus divided by U plus U minus. When you add the sum, you get U plus U minus U plus U minus. This is cancel, we get 1. So the transport number of cation plus transport number of anion is always 1. So transport number of cation and transport number of anion is always 1. If the transport number of cation is known, if the transport number of cation is known, then the transport number of anion, can be determined because we know that transport number of cation plus transport number of anion is equal to 1. If the transport number of cation is known, then T minus is equal to 1 minus T plus. So this, if transport number of cation is known, transport number of anion I want to find out, then transport number of anion is 1 minus T plus. That means it is clear what is transport number. Transport number means the current carried by cation and current carried by the anion. Transport number of cation means the current carried by the cation. The current carried by the cation depends upon the speed of the cation. The speed of the cation, if the speed of the cation is more cations will move towards cathode and more cations get discharged and more current it carry. Similarly, the transport number of anion means current carried by the anions. The current carried by the anions depends upon the speed of the anion. The speed of the anion. If the speed of the anion is more anion will move towards anode and more anions get discharged. And whatever be the current carried by these anions is the transport number of the anion. So the transport number of cation plus transport number of anion is equal to 1. If one of the transport number is known, the other can be determined. But then we can relate the transport number into the speed ratio. How the transport number is related with speed ratio? That means we know that transport number is equal to U plus divided by U plus U minus. Now we want to find out the speed of the cation and speed of the anion. That means you divide throughout numerator and denominator by U minus. So T plus is equal to u plus divided by u minus divided u plus divided by u minus plus u minus divided by u minus. Then what you get? U plus by u minus. If I take r, speed ratio I take, and this is also speed ratio. Here minus minus cancel, plus 1, where r is equal to speed of the cation divided by the speed of the anion. So this is the relationship between the transport number of cation and the speed ratio of the cation and speed ratio of the anion. Similar also, the speed ratio of the transport number of anion and speed ratio can be calculated. How? Now T minus, we know that u minus divided by u plus u minus. Divide throughout by u minus, then you can get what? Now speed of the, that means in this way also you can calculate by dividing, or you can directly calculate. We know that transport number of cation plus transport number of anion is equal to 1. I want to find out transport number of anion. So transport number of anion is equal to 1 minus transport number of cation. So transport number of anion is equal to 1 minus transport number of cation is r divided by r plus 1. Then we get r plus 1 minus r divided by r plus 1. Plus or minus cancel, 1 by r plus 1. So this is the relationship between the transport number of anion and the speed ratio. Or you can also, from the transport number of anion also you can determine. How? Now transport number of anion is anion divided by u plus u minus. Divide throughout by u minus divided by u minus divided by u plus divided by u minus plus u minus divided by u minus. When you get transport number of anion is equal to 1 by, this is the speed ratio, cation by anion, speed r plus 1. So this is same as that we can calculate from here, same. So speed ratio means transport number of cation divided by the transport number of anion. This is the relationship between the transport number of cation and speed ratio. We also relate the transport number with the ionic conductance. How the transport number is related with ionic conductance. In the same cases, we have to take a electrolytic solution. Let us consider we take a electrolytic cell, we put some water, add some electrolyte, suppose I write A, B, electrolyte I add, I diluted to make it infinite dilution. That means we have to add large excess of solvent. So that the electrolyte is completely ionized. In case of weak electrolyte it is completely ionized. In case of strong electrolyte also it is completely ionized. So we have to make it diluted it infinitely. So whatever with the ionic, in this case what happens, the ionic conductance of cation is lambda C naught. Naught means infinite dilution, C means cation. So this is the ionic conductance of the cation, because the electrolyte dissociate into A plus B minus. This is the cation, this is the anion. So at infinite dilution, what are the ionic conductance? Is lambda C naught. Similarly, the ionic conductance of anion. Ionic conductance of anion is lambda A naught. This is the ionic conductance of the cation and ionic conductance of the anion. These ionic conductances is proportional to their speed Suppose I tell that lambda C naught is proportional to U plus and lambda A naught is proportional to U minus. The ionic conductance of cation and ionic conductance of anion depends upon their speed of the cation and speed of the anion. So ionic conductance of cation proportional to the speed of the cation. If the speed of the cation is more, then ionic conductance of cation also at infinite dilution also more. If the speed of the anion is more, then the ionic conductance of the anion is also more. So all depends upon the speed. Similarly, we know that the transport number of cation is U plus divided by U plus plus U minus. That means current carried by cation or speed of the cation divided by total current or the sum of the speed of the cation and anion. In place of U plus you can write UC naught divided by lambda C naught plus lambda A naught. We know that when the solution is completely ionized, we can write molar conductance or equivalent conductance is equal to the sum of the ion is infinite dilution of ionic conductance of the cation and anion. So in place of this one, I can write lambda C naught by lambda EQ naught or lambda M naught. You can also write lambda M naught. Nothing is wrong. So this is the transport number of cation and the relation between the transport number of cation and the ionic conductance. Similarly, the transport number of anion is U minus divided by U plus plus U minus, which is equal to lambda A naught divided by lambda C naught plus lambda A naught. This is nothing but lambda A naught divided by lambda EQ naught. This is the relation between transport number of anion and ionic conductance of the anion. So in this way you can find out the relationship between the transport number and the ionic conductance. Let us consider the equivalent conductance of a let C gram equivalent of the electrolyte dissolving 1 liter, that means 1000 cc of solution. Then what is the equivalent conductance? The equivalent conductance is equal to conductivity by specific conductance into 1000 divided by C. This is in place of normality I write C gram equivalent. So this is the relation equivalent conductance and 1000 by C. Let us consider a cube. Let us consider a cube of 1 centimeter length, 1 centimeter breadth and 1 centimeter height. Then 1 centimeter length, 1 centimeter breadth, 1 centimeter height. Then this is the and all the electrolyte solution are kept in it. That means 1 centimeter length, 1 centimeter breadth, 1 centimeter height gote cube I have to take. We have to take 1 centimeter length, 1 centimeter, that means this is 1 centimeter, this is 1 centimeter, this is also 1 centimeter. And in this 1 centimeter cube, we have to put electrolytic solution. Okay, and this is the equivalent conductance. Then next is how we calculate is that I write once again this formula because it is required. lambda EQ is equal to conductivity into 1000 by C gram equivalent. And we have to take 1 centimeter length, 1 centimeter breadth, 1 centimeter height. Let in between the cube, suppose in between the cube we apply potential difference of 1 volt. Potential difference V is equal to 1 volt. 1 volt with potential difference we apply. By electric potential gradient it is also called as. So we know, if we simplify this one, we can also write lambda eq is equal to 1 by R L by A into 1000 by C. This is the formula for conductivity. Reciprocal of resistivity is called conductivity, or reciprocal of specific resistance is called specific conductance, because we know R is equal to rho L by A. Then rho is called specific resistance is equal to R A by L. Then the reciprocal of specific resistance is called specific conductance. Reciprocal of specific resistance means 1 by rho, which is equal to conductivity, is equal to 1 by R, 1 by A by L is equal to L by A. So in place of conductivity I write this one by R, L by A. Then what from the Ohm's law, from Ohm's law, V is equal to IR. We know V is the potential difference, I the current, R is the resistance. We apply potential, I is equal to V by R. Voltage we consider 1 volt. So in place of V I write 1 is equal to 1 by R. So in place of 1 by R, I can write I, current in ampere. Then the above equation can be written as lambda eq is equal to I into length is 1 centimeter. We consider a cube of 1 centimeter length. 1 centimeter length, area madhya 1 centimeter square, length into breadth. Length is 1 centimeter, breadth is equal to 1 centimeter. So 1 into 1 into 1000 by C. Now it is become equal to I into 1000 by C. Now what is the current? My aim is I want to find out what is the current flow inside it. So what is the current? Now current flow is equal to lambda EQ into C. This will come to this side divided by 1000. This is the current carried in a unity cell. This is the current carried in the unity cell. କେତେ ସମୟ ହେଲା ଅଧିକା ଯଦି ହେଇଯାଏ ପେନ୍ଟା ନେଇ ଆସ ଅଟୋମେଟିକ୍ କରିଦେଇଛି ପେନ୍ଟା ନେଲା ମାନେ ବନ୍ଦ ହେଇଯିବ time ହେଇଗଲା okay next class we have to discuss about the how the ionic the same current we apply on the speed of the cation and the speed of the anion, and we have to take speed of the cation centimeter per second, speed of the anion also centimeter per second. From this speed of the cation and speed of the anion we relate the current, and from that current we have to make this one we compare with that of the C gram equivalent, the electrolyte solution. Then we, after comparing, we find out the current. In the next class we have to discuss about it. Okay, so today you have to end here. So खुदा हाफिज, घरे बुलबनी सबुआड़े कोरोना पलि आसलानी, गवर्नमेंट सबुआड़े बाघ फाघ छाड़ी देती सब गाँव में, तेणु गाँव बुलला माने बाघ नहीं पलैब, तेणु बिल्कुल जमा बाहर बुलबनी। आज पुणी बाहर कोरोना। ओके, खुदा हाफिज, गॉड ब्लेस यू।